Good evening to all. So this is Selumar from SNS College of Technology and the Department of Computer Science and Engineering. So now I am going to tell about virtual memory concept and operating system with backgrounds. In a virtual memory, so we have a background. We have n number of topics. So that is called first one is a background. Second one is a demand paging, and third one is a copy and write, and the fourth one is a page replacement, and the fifth one is allocation of frames, and the last one is a thrashing. So first one is a background. So in a background, the codes needs to be in a memory to execute, but entire programs are rarely used in a background. So it contains the error code and unusual routines and large data structures. So in a background, the entire program code not need to be at the same time, because of entire program is executed at once. So it is considered ability to execute partially loaded programs. So it may be a program no longer constrained by limits of physical memory, and each program takes less memory while running. So more programs run at the same time. So each program takes less memory, so that it increased CPU utilization and throughput with no increase in response time and turnaround time. So we have a less input and output needed. So the load and swap a program into memory. So each user's program is run faster. So because of virtual memory and is a physical memory. And in a virtual memory, so it is a separation of user logical and memory from physical memory. So it is only a part of the program and needs to be in a memory for execution, and logical address space can therefore be a much larger than the physical address space. In a virtual memory, it allows address space to be shared by several processes. So because of the address space is in used for physical memory, and also it allows for more efficient process creations, and also it include the more programs running concurrently. So in a virtual memory, it is it requires the less input and less output for the loading operation and swapping of two different processes. So in a virtual address space, so it is a logical view of how the process is stored in a memory. So it means the process is continued in the virtual address space. It is usually start at address 0, and the contiguous address is until end of the space. When it is contiguous address is ended, then the address space is transferred to 1. So it meanwhile the physical memory organization of page frames. The page frame is contains memory management unit, and it must map logical or physical units. In a virtual memory, it can be implemented by two ways. So one is a demand paging, and the second one is a demand segmentation. So in this diagram, so this is the virtual memory that is a larger than the physical memory. So in this diagram, we have a virtual memory as well as a physical memory. So in between the virtual memory and the physical memory, we have a memory map. So in this diagram, we have a different pages like a page 0 to page B. So we have a number of pages. The one in a memory heap, we have two different columns. One is a black columns and white columns. The black columns contains to transfer the visual address to physical memory. Then the memory have directly transferred to storage system. So when we want to take files from the physical memory, so we need to access it directly from virtual memory. So not going to the main memory. So this is the virtual address space. So usually the design of a logical address space for a stack to start at the maximum logical addresses. So it likes a ground down, and while it is going to grow up. So in this diagram, we have a maximum and then a 0 point. So in between the stack and heap, so we have a number of data stored in the blue columns. So it is used to maximize the address space, and also it is unused address space between the two is hold. So no physical memory needed until a heap or a stack grows to given a new page. So it enables sparse and address space with the holes left for growth. So in a virtual address space, it dynamically linked to libraries. So because of libraries only to execute the all the virtual address spaces. So in a system, the libraries is shared by a mapping to the virtual address space. In a virtual address space, it is stored the different kind of applications. In a shared memory, so by mapping pages, and it's also read and write operations are into virtual address spaces. So when we are going to use virtual files, we are going to need to update the physical memory also. So So it pages can be shared during a fork system calls, so it is included to speeding the process creation. So these are the virtual address space in virtual memory. So this is the shared library using virtual memory. So we have two different virtual memory with shared pages. So both are going to send the data from each together. So this is the reference for virtual memory and background. And thank you so much.